So what I'm going to do is not do any one individually. I'm just going
Yeah.
to explain to you really quickly what this is, this difference quotient, just real quick, and then we'll go through and do an example, and if we need more, then we can do more. But basically what the difference quotient is, remember what that symbol stood for?
The difference quotient, isn't that the
Not the difference quotient, just this.
this? Oh, isn't that just x, pretty much?
Well, this M stood for slope.
Slope. Oh yeah, yeah.
And remember the slope, we needed to know 2 points. So if I had a grid, right, and I just took two random points, say this one and this one,
Mm-hmm.
well, I can then draw a line through those 2 points, and therefore we could find what is called the slope, which was the rise, how much it went up or down, over the run. And if we drew this line and we had this slope, it shouldn't matter if I go up and over or down and over. It should still be the same slope of that line.
Okay.
So the orientation that we do this, as far as which one we put first and which one we put second, doesn't matter. It's just a matter if you're going up the hill or down the hill. So what I'm going to do is I'm going to label these real quick, and I'm going to call them certain things, like we'll call this first one x1, y1, and then this one x2, y2, because then that generalizes things, right?
Yeah.
Like we said, we could find the slope between those by just finding the difference in our y values, which would be the y2 minus the y1, which would be here versus here. And that would tell me how much up or down I went. And then we could find, since we did the y2 minus the y1, because it's usually the bigger one, that will give us positive things when we're subtracting. Then we're going to have to do the x2 minus the x1, which again would be looking here for the x2 and then here for the x1. And again, this would be the bigger because we know the further right we go on the number line, same thing to that, right? And this would
Mm-hmm.
be the y1 and the y2 if you wanted to label those as well.
Okay.
Okay? So if we wanted to change the way that this looked, then we can do something a little bit different. And we can say, all right, well, this is x, and this is some other x, but they're different, right? So that's why we called it x1 and x2. And this was y, and this was also some other y. So since they're different, y1 and y2. But if we wanted to call this line here through those 2 points a function of x,
Mm-hmm.
then the way we find these things and label them is a little bit different. Okay? And what we would have to do then is say, all right, well, if this is the x value, then how do I find the y? Well, we would say, well, this is x, but then to find the y, you'd go to your function and you'd plug in x to find the y. So a little bit different look. And then this would be the same thing, but now we'd be putting in x2 where this was x1. And then we would have f of x2. And so all we would have to do to this equation, which always finds a slope, is then change those values. Which one thing that would not change would be our x's, correct?
Yes.
And then our y's would change though, right?
Yeah.
This is kind of a mess, having all these little ones and all these little twos we call subscripts. So what they decided to do was, instead of calling this a different x and that a different x, they said, you know what? We're just going to call them x, right? Because we know they're x values, but we're going to say there's a difference, the gap between them, and we're going to call that h.
Hmm.
Well, then if this is x, then how big would this one be if I know that there's a gap here of distance h?
Mm.
It's okay. It's a tricky question. Just what do you
Yeah.
think?
Um.
Let me throw in numbers. Let's say this was a 2 and this
Okay.
was 5. What would this be? If this were
Wouldn't
2 and this were 5.
you have to find out how many numbers are in between 2 and 5, and probably put that there too, if that's the halfway point?
Right? Because if this is 1 and this is 2,
Yeah.
And I'm saying that this is a gap of 5. You already know the difference between them.
Yes.
It's 5. So what number would this be?
Um,
If we're starting at 2 and then we're going to march 5 over, what number would that be?
8.
How'd you get that?
I just figured out how many numbers were in between 5 and 2, and then added that to 5.
So if it was at 2 and we march 5 more, right, then it would be at what number?
So, oh, 7. My bad.
7. That's okay, right? So how would we get that and generalize it? Well, if this is x, then this would be x plus whatever that h gap is. So if I rewrote this, instead of all of those x1s and y1s, right, and I erase this here,
Mm-hmm.
what would it look like? Well, if this is just now x, then I could say that this is x comma. How would we find the y value? Well, remember, this is what we called our y's. So it would just be f of x. Where this one, if this is now our x value, then that would be what I put in for x. And that would also be how I evaluated and found my y. So if I change out all the x1s, y1s, x2s, y2s with those new coordinates in green and found my slope, watch what happens. Let's replace them all with what they are now. So let's say y2, that first one here. What did we call that now?
Y f of x. Oh, f of x plus that's an h? Yeah.
Yes, it is. Because of y2. You were right about y1. Very good. So I will put in that blank there a what?
A f of x plus h.
Good. Which is just a y value for that new number, like our 7 that we had, right? If this were 2 and this were 5. Okay, good. How about my y1? What did you say that was?
F of x.
Good. Starting to look familiar?
Yes.
How about
We
my x2?
um we have those numbers, so wouldn't that be? Oh
Good.
wait,
I'm
no.
going to keep it generalized. I just wanted to show you how they could still be the same, right? But we
Oh yeah.
said our x2 was this x plus h.
Okay.
And then our x1 we left as what?
Just x.
Just x. So all we ever want to do with math is make it look simpler. So we're going
Mm-hmm.
to try to simplify this slope with the new form. And on top, is there anything we can do? Can we take f of this and subtract f of that?
Yes.
So what would you get if you took f of x plus h and subtracted f of x?
When you just get h?
No, and that's the problem because remember, we don't know what our function is yet.
Uh-huh.
We know it's a line, but they didn't give us the equation for that line. They're just telling us in general it would be something. So right now, no, unfortunately, we can't do anything, but you're correct about the bottom because the bottom says to take this and subtract that. And can we take an x plus an h and subtract an x from that?
Yes.
What's going to happen?
It's just gonna take away the x, and we're just gonna have h.
And that, my friend, is what is called the difference quotient. Why did they name it that? Because we are left with a quotient or a division problem that has the difference of both your y's and your x's, which, by the way, we already called slope.
Huh.
It's just our slope formula. That's it. It's just in a new format.
Okay.
Instead of these yellow x1, y1, x2, y2 coordinates, we're calling them x's and f of x's as our x and our y. And then we're going to add this little gap in between to known x's. And if I start at this one and I add that gap, then this one is going to be this plus that. That 2 plus 5 to get our 7. Or x plus h to get our x plus h. And that will be our second value that we could then plug in to find our y to our function. But it's still just finding the slope. We will just use it for different things when you get to first semester calculus. We'll add in this thing called a limit, and we will make our h, that gap down here, get closer and closer together so it gets smaller and smaller and smaller so that these 2 points keep approaching each other until they become 1 point. Okay, but again, that's calculus level. We're just doing the algebra level. Okay, so let's put it all together now that you understand what it is, hopefully. At least a little bit better than you did before.
Better
right?
than, yeah, we'll go with that.
It's a different concept. But for us, all we need to know is the equation. And then they're going to give us a function and have us evaluate it. So do you want to start off with the basic one like a line and then do one that is parabolic in shape, like an x squared function?
Sure.
All right, let's start off with an easy one. So we'll just call this number 1 or example number 1. And let's say I gave you f of x, or I could just say y equals, let's do 2x plus 3. I think yours was 4x plus 3 or something like that, right?
Yes.
Now remember, what are we trying to find here? Well,
The f of x.
no, they already told us what f of x is.
Oh, okay.
We're trying to find the difference quotient, which if you remember is just our what formula?
Slope.
That's right. It's our slope formula written in different terms. That's it. Loudon, look at this problem and tell me what is the slope of it?
The slope is eh,
This is why we did that
oh,
whole
y plus b. I'm sorry. I'm very slow.
Okay, it's all right. This is why we did those whole 2 chapters of review during the first 3 weeks, so that we could see things that we already recognize and know. We brushed up on things. You should already know the slope of this is 2. So I already anticipate
I see it.
the answer to this being 2. So
Okay.
let's check it out and see if our prior knowledge will serve us in this. Okay, so I got to do this minus that all over h we just deal with.
All right.
Now remember, the x is just a placeholder. If I was to actually physically write this out, it would be like this. And you'd be standing there waiting. What do you want me to put into those blanks? Well, rather than leaving it blank, which looks unfinished and weird, we put a placeholder called x, which is called a variable, because what can go in there?
Anything.
It can vary. That's right. Anything. Very good. So don't we already know this?
Yes.
Well, then plug that in. The only work you ever really have to do on these is this, which says to replace those placeholders, those x values, with what?
With your slope or whatever the equation is down there.
No, they already gave us the equation.
Oh.
They're telling us to go to our function and replace the x with a what?
With
X plus h.
huh.
Right? Remember I just did this?
Yeah.
Here, let me actually write it. Physically, I'm going to write it out. I know f of something is 2 times that thing plus 3. And remember, the x is just the unknown, the placeholder. They say to do f of this. Now, I know you want to say f that and just leave, but f of this means I got to plug in place, since they did it, with a what?
With an h. Or
x plus h, then I also, wherever there's an x, have to replace it with an x plus h.
okay.
All right? And that is just the first blank to this problem that we have to fill in. Because like you said, they already told us f of x, didn't they?
Uh-huh.
So then I'm going to replace what f of x is equivalent to. It's the 2x plus 3. But I also need to then replace and evaluate what they told me to here as well,
Mm-hmm.
which is what we're going to do here. And what can we do here to make it look a little bit simpler?
We can put, I know we can like multiply 2 into the parentheses.
Very good. We call that distributing.
Yeah.
So that would give us 2 times our x plus 2 times our h plus that 3. And like you said, only to the parentheses.
Mm-hmm.
So that means now we know what f of x plus h is equivalent to. This. So then that will go in here,
Oh.
which is 2x plus 2. Sorry. 2h plus 3. And this is where a lot of students get mixed up on these. It's not that difficult. It's just, do you understand what that connotation is? You know
Okay.
what f of x is. They gave us that. You know what h is. It's always that.
Mm-hmm.
Only work you have to do is this. And if you notice, I put the parentheses or the brackets because I replaced all of these things with more than just one thing, which is what it was here and here. Because this right here is where most students make the mistake, if not here. They won't put the parentheses or the brackets. And guess what they will forget to do? They will forget to subtract the entire function. They will not, like you just said on the last one, distribute. And that's where most people make the mistake. So I'm going to distribute this, and then I'm going to simplify, like we always try to do. This I will just bring down, 2x plus 2h plus 3. This I will distribute and get a negative 2x minus 3, and don't forget it's all over h. And what can we do with that?
Further simplify it.
How?
Find like terms and then kind of just do the math between those like terms on the top of the fraction,
Which give us what?
which let me see. You get rid of 2x, so you get rid of the 3 too, so you just have 2h over h.
Which, can we cancel the h's?
Yes.
As long as they're multiplying, I know anything divided by itself is 1, and 1 times that thing will give me, hey, isn't that exactly what we said the answer probably should come out anyways? Because we know what we're actually finding, which is just our slope.
Yeah, I guess.
Pretty cool, huh?
Yeah, I mean it's a kind of
No, it's not pretty cool. You're like, well, then why the heck would we do all this? Right? Well, there's
yeah.
a big reason why, and again, I'll go over it right now, but I won't get into too much of the calculus version. But remember, what we're finding is the slope. And the cool thing about this is it finds the slope for any function at any point.
Hmm.
And when we're dealing with lines, what is the slope here, 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 everywhere? What is the slope?
2.
Good. It's the same. Whether it's 2 or negative 1/2, whatever it might be, you're absolutely right. But what about something like this? What's the slope of that?
Um,
Yeah, see, now I got you. It's not as easy, right? So that's what the difference quotient actually finds for us, is the slope at any specific point for any function. The problem is, if it's not a line, then it's not the same everywhere.
Okay.
All right. So that means we will also have a variable for our slope, which is weird. And that's where calculus comes in.
Oof.
Don't worry about it. Don't stress. But this is just the beginning of it. That's why we're doing it in our algebra class rather than we're not at calculus yet.
Okay.
Okay? So let's do the difference quotient, which remember is just the difference in our y values
Mhm.
over the difference in our x values. We're just calling that difference h now, which is why this is the first x, and this one is that gap of x plus h. All right, so let's
Yeah.
do something different like this. Now, here's the other cool thing. Remember how we were able to look at this one and we knew the slope because it was in our slope-intercept form?
Hmm.
You will learn after going through some of these hardships at the very beginning of calculus, you will learn to look at this and also be able to tell me the answer or slope immediately, which means we won't have to do this forever. So that's the cool thing. We'll call it the derivative and give it that symbol, which is this whole process without going through that whole process.
Okay.
But unfortunately, now you're like, man, I don't want to go to calculus. But now you're like, okay, take me to calculus if that means I get to skip doing all this. So remember, we got a couple of things we're looking at here. We want to evaluate that minus that over that. And of those things, we know 2 out of the 3, don't we?
Yes.
Which 2?
We know um the f of x,
Very good. They told us what that's equal to, so we will just put that in here. And we definitely know the what?
the h.
Yep, that doesn't change. When we get to calculus, we're going to try to get the h out of there.
All right.
Double entendre, okay? Get the heck out of calculus, but we're also going to have to get rid of that h. And I'll talk to you more about that when and if you take me for calculus or whomever you take, okay? But for now, all we really have to do is evaluate this, which remember, f of something is equal to 6 times that thing squared minus 5 times that thing. That's what this is saying.
Okay.
What did they replace the unknowns, the x, our placeholder, with?
X plus h.
Good. So that means I'm going to take that and I'm going to replace everywhere I saw an x with the x plus h into my function and evaluate it because I want to know what this is equivalent to
Oh, okay.
in its simplified form. Which remember all the order of operation PIMDOS stuff we reviewed in the first 3 weeks?
Yes.
Here it comes again.
Ah,
Parentheses, no. Exponents,
yes.
yes. I have to square this, and this is one of the most commonly seen mistakes with students. They will just square the x and square the h and call it good. No. Remember, x plus h squared means this. It means I have whatever that thing is times itself twice.
Oh, so I have 2x and 2h.
Kind of. You have to FOIL and distribute the x to both of those and the h to both of those. So you are going to get an x squared. You are going to get an h squared, but you're also going to get an xh. How many times?
2 times.
That's right. Very good. So I'm going to rewrite this as 6 times the x squared plus 2 xh's plus an h squared. And then I'm going to go ahead and distribute this -5 to get that step over with. And get that. And then I will also take and distribute what?
The 6.
Very good. So then that is just going to make all of these 6 times bigger. So I will get 6x squareds plus 12xh's plus 6h squareds minus the 5x minus the 5h. And is there any other cleaning up, combining of like terms like you said before that I can do to that one?
Yes.
Which?
The
Which of those 5 can we combine? Which 2 are the same?
the 5h and the 5x. Can't those go into their squared counterparts?
So the 5x is the same as 6x squared?
No, it's not. Never mind.
It's okay. 5h and the h squares?
No.
No, and you said it. I just wanted you to hear it. No, you can't take the 5x or the 5h, which sound different because they are, with their squared counterparts because they're what?
They're not, yeah, they're squared.
They're squared. These are to the first. Then they're not the same. Remember, the only thing that can be different is how many you have, the quantity. Everything else has to be the same. So unfortunately, what does that mean we just found here?
That's the difference quotient?
Not yet. That's
Or,
just our f of x plus h.
oof.
Yeah, these can get laborsome, they can get large. So I'm going to put all of this stuff in here, which, by the way, is the reason that somebody said, I don't want to ever do this again. And they found a way that works always. So they gave it a name called the derivative, but calculus, right? You'll get there.
Yeah.
Now, all we did, all the work, was find f of x plus h. Took us some time to get all the way down here, but then we put that in here. This they already gave us.
Mhm.
H is h. That's not going to change. So the only work you ever have to do is plug in your x plus h everywhere you had x's and evaluate.
All right.
Once you get that, you plug it in. Don't forget to distribute your negative. You combine your like terms, and we'll see what happens with that h. Okay? So all I'm going to do, so I don't have to write this all out again because it's quite long, is I'm going to take this negative here, and I'm going to distribute it to these two things. And when I do that, I'm just going to get the opposite. And now I can just add. Okay?
Mhm.
So I'm going to distribute that negative there and there. Now I can add, and what are my like terms? Up
Uh,
top.
6x squared. You can cancel those out. 5x.
Loudon, notice the pattern here. Just like in the last one, we were able to cancel all the things that didn't have a what in it.
Um, in h.
That's right. Very good. Check this out.
Okay. So let's say,
Now,
if you're on my track, if all you have are h's left.
now, why is that true? Well, remember, if I take f of x and I take that same thing and I add that little gap that I was mentioning to you, our h represents, if we take the f of x plus a little, we're calling h, and we subtract the f of x, shouldn't the original functions basically cancel out?
Mm-hmm.
And we're just left with that little gap into our original function. That's exactly what happens every single time. So my 6x squared, negative 6x squared. My negative 5x, positive 5x. All cancels out, which means what are the only things that are left?
The h's.
Now, again, they're not just h's because that x right there, but things with h. And if all of these that are left have an h, can't I factor the h out of there?
Yes.
Which would leave me with what?
12x plus 6h minus 5.
Very good. And don't forget it was all over the h. But now what does that allow me to do?
Um, further divided by h?
Yes, because these are multiplying. And we know anything divided by itself is 1. And we know 1 times that will give us that. And that's the difference quotient.
Oh, okay. Much more clearer now.